Schrodinger wave equation. Schrodinger equation is one of the basic equation in quantum mechanics. This equation plays the same role in quantum mechanics as Newton's law does in classical mechanics. Using Schrodinger equation, we can calculate the motion of a quantum mechanical wave, just as from Newton's law we can calculate the motion of a classical particle. There are two forms of Schrodinger equation. One is time-dependent Schrodinger equation and time-independent Schrodinger equation. Time-dependent Schrodinger equation. Consider a particle of mass m moving with the velocity v along the positive x-axis. Therefore, the differential equation of the wave can be written as dou square psi by dou x square is equal to 1 by v square dou square psi by dou t square. The solution of this wave equation is of the form psi is equal to a e raised to I kx minus omega t, or psi is equal to a e raised to minus I omega t minus kx. Now this wave function we are going to express in terms of energy and momentum. We know omega equal to 2 pi by t is equal to 2 pi nu is equal to 2 pi h nu by h. H nu we know it is equal to E. Therefore, omega can be written as omega is equal to E divided by h cut, where E is the energy of the particle and h cut is h by 2 pi. The propagation constant k is equal to 2 pi by lambda, and lambda, the de Broglie wavelength, is equal to h by p. Therefore, k can be written as k is equal to 2 pi p by h is equal to p by h cut. Therefore, the wave function can be written as psi is equal to a e raised to minus I by h cut et minus px. Taking the partial derivative of psi with respect to t, we get dou psi by dou t is equal to minus I e by h cut psi. So we can write E psi as E psi is equal to I h cut dou psi by dou t. Taking the partial derivative of psi with respect to x twice, we get dou square psi by dou x square is equal to minus p square by h cut square psi, or p square psi is equal to minus h cut square dou square psi by dou x square. We know the total energy of a particle can be written as E is equal to p square by 2m plus v, where E is the total energy, p square by 2m is the kinetic energy, and v the potential energy. Multiplying throughout by psi, we get E psi is equal to p square by 2m psi plus v psi. Substituting for E psi and p square psi, we get I h cut dou psi by dou t is equal to minus h cut square by 2m dou square psi by dou x square plus v psi. This is called a time-dependent Schrodinger equation. Time-independent Schrodinger equation. Now we are going to write the wave function in terms of position-dependent term and time-dependent term. Psi is equal to a e raised to I omega t into e raised to I kx. Psi can be written as psi is equal to psi 0 e raised to I omega t, where psi 0 is equal to a e raised to I kx. Now taking the partial derivative of psi with respect to t twice, we get dou square psi by dou t square is equal to psi 0 minus I omega the whole square into e raised to I omega t, which will reduces to minus omega square psi 0 e raised to I omega t. That is equal to minus omega square psi. We know the differential equation of a wave, dou square psi by dou t square is equal to v square dou square psi by dou x square. Substituting the value of dou square by dou t square, that is minus omega square psi, in the differential equation of a wave, we get minus omega square psi is equal to v square dou square psi by dou x square. We know omega by v is equal to 2 pi by lambda. Therefore, substituting the value of omega by v in the wave equation, we get dou square psi by dou x square is equal to minus 4 pi square by lambda square psi, where lambda is the de Broglie wavelength, and the de Broglie wavelength is given by h by mv. So when you substitute lambda value, we get dou square psi by dou x square is equal to minus 4 pi square m square v square by h square psi. Now bringing the term in the right side to the left side, we get dou square psi by dou x square plus 4 pi square m square v square by h square psi is equal to 0. Or we can write as dou square psi by dou x square plus p square by h cut square psi is equal to 0, where p is equal to m into, or p square is equal to m square v square, and we know h cut is h by 2 pi. So 4 pi square by h square will be equal to 1 by h cut square. So the final equation is dou square psi by dou x square plus p square by h cut square psi is equal to 0. Kinetic energy is equal to total energy minus potential energy. Multiplying throughout by m and rearranging, we get m square v square is equal to 2me minus v. That is, m into v is p. Therefore, p square is equal to 2me minus v. Multiplying throughout by psi, we get p square psi is equal to 2me minus v of psi. We know that dou square psi by dou x square plus p square psi by h cut square is equal to 0. Substituting for p square psi, we get dou square psi by dou x square plus 2m by h cut square e minus v of psi equal to 0. This is called the time independent Schrodinger equation.